It's Steel Mountain, isn't it?
It's Steel Mountain.
The hacker's dilemma.
We're going to go ahead and do this in the real world, David.
I didn't see you enter any authentication stuff here.
Bingo.
There's no authentication, no.
Hey everyone, it's David Bombal back with Occupy the Web. If you haven't watched our previous videos before, he's the author of this book, fantastic book if you want to learn Linux from a hacker's perspective. He's also the author of this book if you want to learn to become a master hacker. This book has been updated, is that right, Occupy the Web?
Yeah, and it's going to be published by No Starch. There'll be a new version, and it's going to be called the Cyber Warrior Handbook. So it's going to be really a new book with new material in it, but we don't expect to have it out until winter at the earliest, next summer at the latest.
So for anyone who hasn't seen the previous episode, I've linked it below. This is the best kind of videos ever. We get to go through Mr. Robot, and Occupy the Web explains what's going on.
I think we're on season 1, episode 5. Did you do your homework and watch Mr. Robot?
Hello, friend.
I did.
I think I watched that episode like 3 times this week, just to make sure I got everything right.
It's Steel Mountain, isn't it?
It's Steel Mountain.
The hacker's dilemma.
Iron Mountain is the real one, isn't it? I think you said.
Iron Mountain's a real company that actually does almost exactly what Steel
really
Mountain
good.
does. Yeah.
So, Master OTW, please continue. I don't want to stop you.
Those of you who are familiar with the series know that there has been a hack of Evil Corp, right? This big conglomerate that basically owns everything that Elliot actually works to protect, but he really hates because, in part, they killed his father and his friend Angela's mother. And that's part of the storyline here, why he really dislikes this huge conglomerate. The hack was basically a form of similar to ransomware. So what they've done is they've encrypted all of the data on the servers. This corporation is the largest in the United States, maybe in the world. They're a big financier. They have a bank and they have many other activities. When their servers go down, it causes a lot of consternation and difficulties in the economy. The economy basically collapses. So the strategy at this point is that Evil Corp, of course, has backups. So even though F Society has encrypted all their data, they have tape backups. And like most major corporations and even small corporations, there are backups stored off-site. Big corporations in the US, at least, use a company that's called Iron Mountain. The company in the Mr. Robot is called Steel Mountain. And one of the services that they offer is to store tape backups in a secure location where it's climate controlled. They have HVAC systems that control the humidity and the temperature so that your backup data never gets destroyed. Elliot and his crew have decided that they have to get to the tape backups so that Evil Corp can't restore the data. Now, this data is all stored on tape. And you might say to yourself, hey, who stores the data on tape anymore? Well, a lot of people still do. And so they've got to go ahead and somehow destroy the tape. And they realize that the tape will basically, this is electromagnetic tape, right? And so it has a film on it that stores zeros and ones. They figure out that if they can raise the temperature of the tape, that it'll basically disintegrate and lose the data. So their plan is to get their way into Steel Mountain, this highly secure environment that's a ways away from New York City where they're based. And they want to get inside the HVAC system, which, by the way, is a SCADA ICS system, right? Almost all of the HVAC systems are SCADA ICS. So this is really, once again, a SCADA ICS hack, similar to the last one we did. These are all run by these PLCs that talk to each other in this protocol that you probably aren't familiar with. In this case, they're probably using Modbus, which is the most widely used. But first, they have to social engineer their way into the facility. And like I was saying in the earlier YouTube videos, is that social engineering is a really, really important part of information security, cyber security. a lot of newbies in the field don't give it its full importance. Even in the most important hacks that ever took place in the history of cybersecurity, there is a social engineering element. The same with this hack. In our first video we did, there was a social engineering element there too, where they had to get the policemen to turn away from the system so they could hack the Bluetooth. In this one, there's even a bigger social engineering element, and that Elliot has to find his way physically into the facility. Now, I find it interesting that Elliot has to find his way into the facility and they didn't try to hack this from the outside, because many of these facilities you can access over TCP/IP. It may be that this one was offline and he couldn't access it. I doubt that's the case, but it makes a more interesting story if they have to get inside.
Yeah.
So they're trying to get inside. Elliot works his way in, tries to social engineer his way in, and he's got a Raspberry Pi with him that he wants to connect into the network to be able to turn the temperature up in the facility that holds the tapes.
Is that real world that the tapes will melt or whatever, lose their data if the temperature goes too high?
I'm not really sure, but I would suspect that is true. Right? That's why you store your tapes in these climate-controlled facilities. Most data is susceptible to either static electricity of having too low humidity or susceptible to too high or too low a temperature. So that's what these companies sell, is they sell a climate-controlled facility that your data will remain intact for decades if need be. In the show, they say 97 degrees Fahrenheit is where it begins to disintegrate. That sounds reasonable to me, but I haven't tested it. And so they social engineer their way into the facility. Elliot pretends to be this tech billionaire. Eventually, they run into some difficulties in trying to be able to get to the facility they want. They want to get into a particular vault where Evil Corp's tapes are being held. They decide that what they need to do is to send a spoofed SMS message to the woman who's talking to Elliot. As you can see on my screen here, we have the social engineering toolkit. This is what they use in the show. It's no longer in social engineering toolkit, all right, because it's run into spoofing SMS is run into legal issues in the US. In my book, Getting Started and Become a Master Hacker, I actually recommended a site, Spoof My Text. This site used to be able to spoof text. You can see here, it used to be able to send in a sender number and a recipient number, and you could put anything, and it worked great until just about a year ago. You can see it says maintenance. We currently only support the sender ID. Because the law has cracked down on this service, it's more difficult to be able to spoof SMS. There are ways, though, that we can send an SMS message to anybody in the world. And this is one that comes from a site called textbelt.com. And I think they'll let you do one free text a day. But if you want to do more than one text a day, you have to purchase it. And you can see that I only have 48 remaining right here. And this is right here. Let me show you the basic syntax. It's a curl command, which, by the way, we have advanced Linux coming up next week, and is one of my classes, and we'll be working with curl command among other things. But in any case, curl-x post, and it goes to their website, and then it's data URL encode, then the phone number you want to text, and then the message, data URL encode, message. The message has to be in single quotation, so is a phone number, and then it's -D, and then the API key that you get from their website. On the show, the message that was sent to the woman who they were trying to get rid of was a message that basically said there was a medical emergency and that she then had to leave. She was upset over getting this message that there was some medical emergency. So what I've done is simply create a message that says, "This is St. Thomas Hospital." Of course, we could expand the message. And I'm going to send this to David. So let's go ahead and do this.
That's a real number on my phone, which I've got here.
I'm going to go ahead and send you a message.
Go for it.
All right, so this is what message I've been getting from them lately. It says, "Sorry, ability to send URLs via text is limited to verified accounts. I get this on occasion. They're trying to limit people sending URLs. For some reason, they see my message as a URL." Let me try again. There we go. It went through this time.
And there you go. Yeah, it's
Does
arrived
it show
already.
up there?
Yeah, I've
Okay.
got 3 because you sent it previously in a test, but the third one's just arrived. Yep, just arrived.
Let's try it again. Make sure it works again.
Yep. Do you want to change the message just so that, for all the people telling us that we're faking this?
Okay, let me do that. See it here in orange here. David, we need you now. All right.
Yep. And there we go.
Did it come through?
Yep, it's already here. This is really interesting because you're based in the US and I'm based in the UK, and you've just sent an SMS. It's showing up as a US number that I've received, yeah.
Now, the only limitation, of course, of this is that I can't use any phone number as a sender number. It used to be that you could until recently. This is next best thing. We can send a message and say, hey, this is the hospital. It's an emergency. Come quick, what have you, and be able to distract, in the case of the show, where they distract the woman who's giving Elliot the tour of the facility and basically telling him he can't go where he wants to go, which is where the vault, where all the data is. This is a way that we can go ahead and send a text message to anybody in the world, basically. I mean, this covers about any phone numbers in the world. I think they got like 200 countries that they cover. There's a number of different ways also that you can do this, but this is the simplest and easiest to do. They charge, I think, $3 per 50 messages. So that's pretty inexpensive.
They used to let you spoof the sender, but now because of the legal stuff, you can't do that so easily these days, yeah?
Exactly. Because of the legal stuff, you're going to run into problems with the law. And the sites that used to allow you to do this, the services have all been shut down. Okay, either they've shut down or now they'll just let you send a SMS message, but coming from their phone number, just like this one here. It comes from a U.S. number because this is a U.S. service. So somewhat limited now because of the law.
But like you said, the idea is that she was distracted and distraught because she got a bad message, and then she walked away and left Elliot alone. I don't know what St. Thomas's Hospital's number actually is. So, I mean, it's you can see why this works.
Yeah, it might. I mean, the only thing is if somebody was really aware, they'd go, well, that's a U.S. number. It can't be St. Thomas. This is actually this is in London, St. Thomas and London Hospital. But if somebody weren't looking very closely, they might be distracted by an emergency coming from St. Thomas Hospital.
You get a lot of strange texts these days, so you don't always know, the origin of that text. But you could have said phone some number, and then she could have phoned. I could have phoned, and then you could have told me. Pretended to be the hospital, couldn't you?
Exactly. There's lots of ways you could use this, as you point out, to be able to social engineer people. One of the things that they won't let you do is they won't let you send a URL unless you're on their whitelist. So if you're trying to use this to be able to get people to click, it says send URLs via text is limited to verified accounts. So you can get on their whitelist and then send URLs. But obviously, if you start sending out links that are malicious, you're going to get on a blacklist instead of a whitelist. But you can send messages and spoof messages to anybody in the world this way.
Perhaps we could just ask people who are in different parts of the world if you've seen systems that are still usable in, not the US, but let's say other countries that can perhaps do it. Like in South Africa, as an example, people get constant barrages of spoof SMSs or, spam SMSs. It's a constant problem. And I think the regulation isn't as good there as in some other countries.
SMS messages has now become a way of advertising. It's become a way of social engineering people. It's become a way to send messages to vast audiences all at one time. So it's become kind of the spam of the phone in recent years.
Yeah.
So. But for our purposes here, this is the closest that we can get presently to what was actually done in the show. Let's move on next to creating our Raspberry Pi hacking system that he's going to use inside the hospital. He's carrying this in his pocket, but before he gets into the facility, he has to build it first. So let's talk about that.
We're not going to cover the cloning of cards. We can maybe cover that in a different video, just for anyone who's wondering why we only we jump to this part of the video or the episode. It's going to get too long, so we'll cover that perhaps in a different one.
Yeah, I'd like to do that in another episode. And
That'd be great.
Clone what he does. They get inside Steel Mountain by cloning an ID card. And, they do it bumping into a fellow in the coffee shop that they know works there. And they basically make a copy of it and then make a new card that they use to enter the system. So if you want to build a hacking Pi, Raspberry Pi, you can see this is at Kali's website. And you can go ahead and get the ARM version of Kali and build a Raspberry Pi with it. So you get a Kali system, okay, on a Raspberry Pi. That's basically what he is doing in the show. You go ahead and you download this and then create an image on an SD card, and then you go ahead and put that image onto an SD card, and then you can boot the Raspberry Pi from that image.
I've created a video showing you that full process, which I'll link below if you want to see, the whole process of downloading and installing and booting it up.
Because of the limitations, I'm going to use limitations of making this video. I'm going to be using, instead of my Raspberry Pi, I'm going to be using two virtual machines. So I've got one Kali 2020 over here, and this is going to be my Pi machine. And then over here, this is going to be the machine that I'm going to control the Pi with. One of the things that Elliot has to do, there are some areas here that stretch credibility. Okay. as there are in all these shows, but really it's closer to reality than any other show. Here's the issue he has to do. If he goes ahead and puts the Pi into the system, into the network inside of Steel Mountain, he has to somehow control it. He has to be able to access it. There's lots of ways that he could do that, but one of the ways that he could do that is to be able to go ahead and create a Netcat connection between himself, his Kali, and the Kali on the Raspberry Pi. So let's go ahead and do that. Let's open up a listener here. All right, so what we're going to do is Netcat, if you're not familiar with it, is a real simple tool that basically allows you to create a TCP connection between any two systems. And so what we're going to do is we're going to go ahead and go sudo netcat, and then we're going to go -L listener -P, which is what port is it going to be on? Okay, we'll put it on 5.9 because this is the 5.9 hack. And then we're going to go ahead and execute, okay, -E, the bin SHA. So let's go through that command. Sudo to get root privileges. NC is netcat as the command, -L is listener. This is the port to listen on. And then this is what we want to execute to somebody who connects to it. I'm going to back up just one moment and check my IP addresses. Sudo ifconfig. This is 107.131. So now we'll go back and we're going to create our Netcat connection. Netcat -L -P, and it can be any port. I'm using 5.9 because the hack in the show is the 5.9 hack. It was May 9th. And then -E, and then bin SHA. What bin SHA is, that's just going to open up a shell for somebody who connects to it. So we got that sitting there waiting. So we've set up our Pi with a listener, a Netcat listener. Now we can go back over here to our system and connect to it. Sudo netcat 192.168.107.131. That's the IP of the hacking Pi system. And then the port. Okay. You can see I got nothing on the screen, right? But I've made a connection, and I'm now inside of a shell in the Pi system. So let's go ahead and just check that and go ifconfig, and you can see the IP address. I can go who am I? I'm root and go pwd. So you can see that I'm inside the Pi system. So now when he puts that hacking Pi inside of the network, inside of Steel Mountain, he has control of it.
Would it have made sense to do a reverse shell, like when he plugged the Pi in, that it does a connection back to this computer, like his laptop?
That's an option as well. All right. So either way, we got to make a connection between these two systems.
He had to have like a 4G or 5G or some kind of cell phone connection from the Pi to the outside world.
What I would have done if I was him, and this doesn't show us in the show, is that I would have made the Pi into a Wi-Fi AP. The issue with that is that it has a limited range. You can make the Raspberry Pi into a Wi-Fi AP, make it into a rogue AP, and then connect to that AP, and then go into the network that way. In this case here, he's going to have to actually be able to hit this public IP address from outside. And remember, we were talking earlier about why didn't he go in from the outside? If it was offline, if this facility was totally offline, then being able to connect to the Raspberry Pi wouldn't be possible. One of the other options, of course, is that he could have developed a script and that script would execute as soon as it got connected into the system. But that would require a knowledge of the system, of the network that he couldn't have had without actually doing some reconnaissance on it. So now that we have a connection inside that hacking Pi, we can start doing our reconnaissance on the network. And so we could go ahead and say do an Nmap scan to see what the IP addresses are in that network. So this would be the first step for him to start doing reconnaissance, to find out what IP addresses there are. So now, because he's connected to the Pi and the Pi is connected inside the network, he can begin to do reconnaissance on the network. And this is where things get, stretch credulity. To be able to hack this HVAC system, it can be done, but you have to study the system. You have to know what the system is before you can go in and actually hack it. So now what we've done is we've gone ahead and scanned what IP addresses are in that system. After he's done that, the next step to be able to hack this HVAC system, remember this HVAC system is a ICS system. It's a SCADA ICS system. And he knows what IP addresses are. One of the things he would look for is potentially he could look for what's called the human machine interface. Somebody has to have monitoring and control over the HVAC system. He can go in and start looking for that system and try to take control of it. Because he's inside the network, that might be simpler than doing it from outside the network. The other thing he could do is to begin to look at what are the various units within the system and begin exploring those units. When I say units, I mean unit IDs. The PLCs all have unit IDs. Let's go ahead and start MSF console. Remember, we're remotely controlling the Pi. We're going to open up MSF console and we're going to do some exploring of the HVAC system to be able to find out what are the unit IDs and other information. One of the things that we want to do here, this is Metasploit if you haven't seen it before. This is a hacking framework. Let's go ahead and just do a quick search and looking for Modbus units. These are the modules that deal with Modbus, and Modbus is the most widely used protocol in these HVAC SCADA ICS systems. Schneider Electric, who's the developer of Modbus, is one of the largest players in the HVAC industry.
I love the story I heard you tell about you used Shodan to find a system online, and just tell us the story. You they weren't very impressed with you, were they? Because you got into the news and stuff, or something like that, yeah?
Yeah, I can show you that. I got it here.
That'd be great, yeah.
Schneider makes these automated building systems. Basically, it's an HVAC system. It controls the temperature, the humidity, locks, and doors, what have you. Here's a sample of what these look like. And what I did in this case is I just went up and got on Shodan and looked for systems that in their banner say that they're Schneider Electric Automation. Looks like there was, less than 100, 65 looks like. I started playing around with them and I just SSH'd into one of them.
So you found the IP address on Shodan, then you just SSH directly to it, yeah?
I just SSH directly into it. Okay, and you see it says, I've logged in here. There was no password to SSH on it.
Wow.
I'm going in as admin. This is 2016. So this is actually after Mr. Robot takes place. So this could have been what Elliot would do. He could have done remotely if the system was online. Okay?
Yeah.
So I went in, SSH'd into it, looked at the help screen on the SSH. You can see I went ahead and just typed release. Notice that I'm in as admin here, right?
It's crazy.
This isn't a test system. This isn't an educational system. This is real live system. And just ran a couple of commands on it. I did the uptime on it and looked at the etc password file.
Just explain that. So you did uptime pipe cat. Can you just explain what you did there?
What I did in this case is this the pipe command right here. So I did uptime and then did cat. That's a pipe and then cat etc password. Etc password in older Linux systems where passwords were stored. Now it's where all the accounts are stored. Passwords are stored in shadow, etc shadow. All right. So I just ran a pipe between uptime and the cat of the.
So you didn't have to use the uptime command. You could have just did cat directly, yeah?
In this case, if I remember correctly, yeah, I had to actually use the cat to get into it. So it says one of the many weaknesses of the system is that we can pipe system commands to the underlying server after these SSH commands. So to get to the underlying server, I had to pipe it. Okay.
Okay, so you run like a valid command, and then you run an underlying command. That's why you did it that way.
And pipe it to the underlying server. With SSH, you're limited to SSH commands. What I'm doing here is I'm using an SSH command, then piping it to an underlying server command. Now I can go ahead and do sudo I, and now I've got root.
And did you have to put a password in?
No, there's no password at all. So and I published this in 2016. This is like, I think it was August of 2016, somewhere around there. And I put this up on Hackers Arise, and you can see I'm in.
Oh, see, now you can do the cat, yeah.
Now I got cat of Etsy Shadow. Because I'm root, I can get the passwords off this system. There's also an area where the whitelist rules, which they were not using, right? And I went ahead and showed you that I could get into the whitelist rules, and I could have gone ahead and added myself on their system, and I would have been in there for an indefinite amount of time. This would be a system similar to what Elliot was trying to get into. I had total control over this building. This is an industrial building. I'm not going to tell you where it's at, but it's an industrial building. After I did this, Voice of America did a big article on the weaknesses of SCADA ICS systems. And they interviewed some people, and they said, the industry is so vulnerable that this anonymous hacker just published an article about how he hacked into this system and got root privileges. And that's how vulnerable the industry is. And thank you very much. That was my whole point, right? And then once that happened, Schneider Electric got very upset, and I got some nasty emails from Schneider Electric. And I said, you guys knew about this. Don't get mad at me about demonstrating to the world how poor your security is. And so we had a lot of nasty back and forth. And then within a couple of months, they went ahead and fixed this vulnerability. So, everybody who runs one of these systems should send me a Christmas card. All right,
exactly.
Because I saved you.
Is it still bad today?
It's still bad today. It's not as bad, but it's still bad. Here's Schneider's website on their building automation systems. This is what they sell. They're probably the biggest seller in the world on these systems. They are the oldest company in this industry. Anyways, let's go on and see what Elliot could do now. There's a module in Metasploit called Find Unit ID. And what this does is that these PLCs within this network all have identifying numbers. They're called unit IDs, kind of like an IP address. There's up to 255 of them. Let's go ahead and just demonstrate what it can do. And I'll just do an info on it. There's also a module that does the same thing. Nmap has a script that does the same thing as this. It says Modbus is a clear text protocol using common SCADA systems developed originally as a serial line async protocol, later transformed to IP, where it's called Modbus TCP. Default port is 502. This module sends a command. It's in hex. It's 04. Read input register to the Modbus endpoint. If this command is sent to the correct unit ID, it returns with the same function ID. What it does is it goes out and tries to find the PLC numbers, essentially, the unit IDs of each one of the PLCs. And so what we're going to do is we're going to go ahead and do this, okay, in the real world, David. So I'm putting you on notice here to building control system. So we're going to go ahead and go set our host. And then now that we've got that set, we'll just do show options. So you can blur out this IP address.
You've got SCADA courses coming up, is that right?
I have a SCADA course coming up in September.
So you'll go through this kind of stuff. The stuff I can't show, you can show in your course. Yeah. So I'll blur out what we need to do, what needs to be blurred out.
And so this is very similar to doing, say, an Nmap scan, but it's in a SCADA system. In this particular, it's a Modbus system. We're trying to find the IP addresses. Maybe it's closer to like a ping sweep, but it's inside of a SCADA ICS system. Let's go ahead and do exploit. Part of the problem of using Metasploit remotely like this on the Hacking Pi is that being able to stop it is difficult because it wants to, if you try to stop, it actually will drop the connection.
Yeah, I forgot you've actually got a Netcat connection to the Pi, haven't you?
Right.
Yeah.
I'm actually controlling the Pi, and the Pi is doing this work. Right.
Yeah.
The Pi is going out and connecting to this system. Now, it'll have up to 254 of these station IDs. And so if we just let it run, it'll take a while. I'm going to try to, we could do that, but for the sake of brevity, it dropped out. Okay. This might actually be in our favor. My connection to my hacking Pi is maybe dropped. I'm not getting any response from it right now. Let's see if I can do an IF config on it. Oh yeah, I got it. Okay, now that we're back now, we've got a command line. I was back in the shell still, right? And I've installed another tool on that hacking Pi that's called the Modbus CLI. I'll go ahead and just show you how to install it here. It goes gem install Modbus CLI. Okay, that's the command. What we can do with this tool, we can begin to probe the memory within those PLCs. We can go ahead and take a look around and see what's in memory. And this is where Elliot, what he's trying to do is he's trying to find the PLC that is controlling the temperature. If we can get to the human machine interface, that would be ideal, because then all he has to do is take the little meter and turn it up, right? That would be, it's unlikely, but it's a possibility. But now that he's inside the system, with some reconnaissance, he can begin working his way through the PLCs, looking for the control that's going to change the temperature. And this is a tool that basically allows him to probe the memory within these PLCs.
I've had to blur out a lot of the video because I don't want to lose my YouTube channel. Occupy the Web did this live, so it's all open. Nothing's blurred. So if you want to see an example of this without everything being blurred and edited, then have a look at the video below.
This is what Elliot would have to do, is to write over those values to be able to get the temperature. So the system, the HVAC system, is going to have a minimum temperature and a maximum temperature, right? It's going to try to keep the temperature between those values. Elliot could then basically, like changing a thermostat, go ahead and change it to raise the temperature to 97 Fahrenheit, and therefore be able to disintegrate and make useless the tapes. This is where it stretches credulity, and that it would take a lot of work. If you worked round the clock at it and you knew these facilities well, you probably could do it in a matter of days, right? But certainly not in a matter of minutes or hours, maybe a month. If you were fully aware and fully understood how this Modbus protocol works and the PLC works. It's interesting that two of the biggest hacks in season one are both SCADA ICS hacks, which I think is the one area of hacking, information security, cybersecurity that is overlooked. People don't give it enough attention. With Cyberwar breaking out between Ukraine and Russia, the attacks now are beginning to go to this level of getting down to the industrial facilities. In any case, this is what Elliot was doing. This is getting inside the facility, putting in a hacking Pi, and then being able to do reconnaissance on the network inside of the facility. And then once he knows what's going on inside the facility, he can begin to change the values inside the facility. Now, the other thing that's important to note here, you can write externally to some of these industrial facilities. What I'll see oftentimes is that I can read externally, but I have a blacklist, or more generally, I have a whitelist of who can write to the facility. He's inside. So his IP address is inside the network. So he's going to look like he's a safe IP address writing to these PLCs. That's another reason why he would want to be inside, because oftentimes, like we saw in the case of that facility that I hacked in 2016, that they have a whitelist and blacklist. You might be able to read from the outside, but you can't write, which makes a lot of sense, right? I mean, that's the way it should be. But Elliot is inside the network now, so he should be able to read and write both.
Is there a special type of cabling used on these systems? How does that work?
In most of these SCADA ICS systems, internally they're using RS-485, which is a serial type of cable. Basically, you had to have power and he
Yeah.
had to connect to the network, right? So he had to have both Ethernet or some connection to the network. So when he's actually in there cutting the cable, that might be a serial cable. I didn't look at it that closely to be able to see, but internally, these networks communicate over a really simple serial connection, kind of similar to what they used to use for printers. We used to use RS-232 for printers. This is RS-485. It's very similar, and it's used in most of the facilities. You'll see sometimes in some of the facilities nowadays, newer ones where they'll actually use Ethernet internally. Many of these facilities have been built years ago, and they're still using serial connections. Modbus and many of the others are all basically serial protocols, even though they will communicate to the rest of the world over TCP/IP. Internally, they'll communicate using Modbus or Profinet or OPC or what have you. There's about 200 protocols. There's about 50 or more companies making these things. Almost all of them have their own protocol. Modbus is the closest thing that we have to a single protocol that's used in multiple facilities because they were first, 1978. When people build PLCs today, they will often still put in a Modbus connection to allow that PLC to communicate over Modbus or their own proprietary protocol as well. This is part of the research that you would do, is to go and look at their products, and they actually have schematics on their website. They talk about being able to connect to multiple protocols. So you see these are thermostats, room controllers. They'll have multiple connections to multiple protocols. Modbus is the one that basically was developed by Schneider. It's the most widely used, but when you say most widely used, we're still talking about less than 50%. So that's what Elliot would do. If he was actually going to go ahead and try to turn the temperature up. One of the things that would make his job even more difficult, if he gets inside this HVAC system, he not only has to turn up the temperature, but he has to turn up the temperature specifically in that one vault.
Yeah.
Make it even more challenging, because if you turn the temperature up in the whole building, right, they would immediately be noticed.
I love what you said, like on the previous episode and other times we've spoken, it's the hacks in Mr. Robot are very close to the real world. It's just the time scales are wrong. Yeah.
He's using the right tools. Okay. He's going about it properly.
Yeah.
But the time frames, because of, nobody's going to sit around and watch, hours and days or weeks of people doing research and reconnaissance. that wouldn't be interesting television. But the tools are right, the approach is right, the techniques are right. It's just the time frames are compressed for the attention span of the folks who are watching the show.
Is there like a simulation, or is the only way to learn this? I think you've mentioned previously, is the only way to learn this to buy the equipment, or can you like simulate it to learn it?
I'm actually putting together a simulation system for the class in September. People have been asking me for a simulation system, and I'm putting one together. You can do it at your own home. You don't have to go out and do it in the real world. PLCs can run anywhere from a few $100s to tens of thousands of dollars. You can get them used off eBay, what have you. But in any case, I'm putting together a simulation system, and hopefully we'll have that ready for the class in September.
Are you going to buy real devices and then connect them and put them together in a lab that people can access? Did I understand that right?
It's not going to be real PLCs.
Okay.
Because if I put together real PLCs, remember they're communicating via serial connections. So we want something that we can connect to remotely over TCP/IP. So it's going to be a simulation. It's not going to be real PLCs.
No, but that's fine. I mean, it's better to learn sometimes on something like that. Are there any books that you recommend? Because let's say I'm interested in learning SCADA. I mean, I can attend your class, but it's only in September. Any other things I can do, like buy books or stuff that you recommend?
The CISA has some good educational materials there. You might take a look at those. There's a number of books. Let me see. Try and remember what the names of those books are. I'll look around here and see if I have any of them on my shelf.
Occupy the Web, I really want to thank you. Thank you so much for sharing and making this fun, because it's really nice to see Mr. Robot and what they're actually doing and the reality of you showing it properly.
Give us some feedback of what hacks you want to see. There's a lot of hacks in this show, right? So let us know what's most important to you, what's most interesting to you, and we'll try to do those.
Brilliant. Thank you so much.
Thanks, David.